Okay, we're going to clarify arcsine, arccosine, arctangent, and talk about how to use your calculator to help you with this and to find solutions, because some of you guys had problems with the Khan Academy assignment, and I just want to make sure and clarify some answers that you may have. So here we go. We talked about, or I showed you how arcsine, arccosine, arctangent, the inverse functions to sine, cosine, and tangent respectively were formed from the graph. The original sinusoidal functions are not invertible for their domains because they're repetitive. So it would fail the horizontal line test. So what we do is we just take a little snippet of the graph and we use that to create these inverse functions. So that way it would pass the horizontal line test. So when it comes to arcsine, right? Arcsine's input should be a trig ratio. Which means that possible inputs range from -1 all the way to 1. And yes, I use brackets because I can have outputs of sine, aka inputs for arcsine, that are exactly -1 and exactly 1. Right? As a result, this will spit out answers ranging from -pi/2 to +pi/2. And let's talk about how this unit circle produces this, right? So we know that sine refers to the sine function. Oh, I guess I shouldn't use x because that's going to get a little confusing. Of t for the angle is equal to the y values. So since we have a circle, right, this graph fails the horizontal line test. So I can't go somewhere like that. Actually, let me try that again. I can't just go straight across because there, for each output, there are two inputs. So I don't invert it on that scale. What I intend to do instead is just focus on something like this. Because if I draw just a horizontal line from -pi/2, so starting here, all the way to pi/2, right? If I block out the purple and like pink areas, that satisfies the horizontal line test, meaning that part can be inverted. So that's why we go from -pi/2, which is all the way down here, to pi/2, which is all the way up here. That's where it comes from. So when you were watching Khan Academy yesterday and you saw Khan doing like pi minus that number, it's because he knew that the solution provided to him in that particular problem was going to be in the first quadrant here. And if sine was going to be positive, he needs the other solution in the second quadrant. So he had to go find it based off the reference angle provided to him. If he had gotten a negative value for sine, then he would have looked over here in the third quadrant to get the other possible solution. So that's what we do with arcsine. So if I say that I'm trying to find arcsine of, I don't know, -1/2, the calculator is going to spit out a decimal, but I should know that arcsine means I'm looking somewhere in here in this range, and I'm looking for the y value to be a 1/2, so I know it's right here, a -1/2. So that means that I'm looking at 11 pi/6. but that's not in the range, so I think about this as a negative pi over 6, right? Because from here to here, it's negative pi over 6 because it's rotating clockwise pi over 6 radians, aka 30 degrees. So once I know I have that answer there, well, I need to find another answer over here. So I take the pi that's right here, and this time I would, I guess I would still technically subtract that angle. So it'd be like pi minus the angle I just found, which should give me that 7 pi over 6. That's this one right here. So notice, by doing pi minus the given angle from arc sine, I could get if it was positive. If the arc sine ratio was negative. And if it was positive, then I would still do the same thing. It would be pi minus the arc sine value. Okay? So hopefully that made sense. Now let's talk about arc cosine and the rule that we would use for arc cosine. So arc cosine of a value, this one, I guess, inside the cosine we would put in x in order to spit out the t. And x is the trig ratio. And that trig ratio can range from -1 to 1. Anything outside that interval, arc cosine will tell you that it's undefined, which makes sense because cosine only can have values between -1 and +1. But this time, the output will go from 0 to pi, right? Because we want to make sure that the given inputs would be invertible. So with the other graph, for the arc sine, I had to do a horizontal line test because I was looking at the outputs of that, which were dealing with the y values. So I want to make sure the y values didn't repeat. For arc cosine, I want to make sure the x values do not repeat. So since I'm focusing on x values, I need to make sure that this would pass a vertical line test in order for the function to be invertible, right? Because this circle right here is not a function. This is talking about both x and y depending on the angle t. So that's why I'm using a vertical line test to figure out where the cosine would kind of be inverted. Okay, it's a little tricky, but just trust me, because if I say that I want to make sure that all the possible cosine values, the outputs, apply. So I want to make sure I go from -1 to 1. So I just cover this half of the unit circle right here. Okay. So let's say we had to figure out what arc cosine of negative radical 2 over 2 was. Okay. If you type this in the calculator is going to spit out an answer between 0 and pi, and the one it would spit out, once you convert it, would be 3 pi over 4, right? Because it's that number right there that we're looking for. But I know that between 0 and 2 pi, there are two places where cosine will equal a negative radical 2 over 2. One's in the second quadrant, which the arc cosine provides, right? Arc cosine will give you a reference angle, an angle in the first or second quadrant, because that's where it's pulling its values from, and that's what I was trying to explain earlier. To get the second value, well, think of it this way. It's saying from here all the way here, this angle of rotation is the 3 pi over 2. I'm sorry, 3 pi over 4. So if I think about like a negative angle, right, I could also just rotate in this negative direction. So I could say it would be 3 pi over 4 or negative 3 pi over 4. And you know what? I would rather you think about it as 2 pi minus the given angle here, right? Because that should get you the 5 pi over 4, which is again a coterminal angle with that negative 3 pi over 4, right? So negative 3 pi over 4 goes clockwise, positive 3 pi over 4, or positive 5 pi over 4 goes counterclockwise. But they both are the same value. So that's how they get the arc sine. That's how you use arc cosine. The last one we need to talk about is arc tangent. So arc tangent is a combination of both sine and cosine, because tangent is sine of x divided by cosine of x, right? And actually for this one, it'd be nice to kind of think about it as the graph. So if you can imagine a sketch of the tangent graph, right? Just bear with me. It looks something like this. It's very repetitive. But to limit its output so that way it can be inverted, because this graph right here is not invertible. It fails the horizontal line test right there. Boom. Crosses more than the horizontal line intersects the graph more than once. So what they decided to do is just this. Let me ignore all this out here, and I'm just going to focus on this part of the graph right there, right? So it's focusing between negative pi over 2 and pi over 2. So when you use arc tangent, let's use z. Z can be any real number, because tangent could equal any number whatsoever. Its output will be bound from a negative pi over 2 to a positive pi over 2. Notice this time I'm using parentheses because tangent cannot exist at negative pi over 2 or pi over 2 or any odd multiple of pi over 2. So when you have a problem like this for the arc tangent, let's say it's arctan of, I don't know, negative 10. Right? That's not one of the special reference angles that, or special values that we know. It's not anything we've seen before, so now we go to the calculator. I would say leave your calculator in radian mode, even though Khan Academy kind of made you switch between the two. And here's what you do. You do second tan of 10. And when you're in radian, your calculator should spit, negative 10. And your calculator should spit out negative 1.47. Tangent has a period of pi, so I know like there's only one solution for a tangent graph like this, and that's it. If I want to find more solutions, I just keep on adding revolutions of pi, aka plus n pi, to get more of them. hopefully this has helped, and we'll work through another example next video.